All right, so we're moving along in the Gaddis book. We are chapter 16, and I'm going to jump out of order briefly because I'd like to cover this first. And one of the things we're going to start out by talking about is something called a function template. Okay, so what happens if I want to write this class, and this class is called int square, int number. I'm bringing in a number and I want to square it, and my return type is an int. If I wanted, I could have made this a reference variable. You did that on your first test back in 161. You brought in two numbers, you squared both of them, but by making it a reference variable, we were able to not need a return type, and we were capable of changing two numbers at once. Okay, so if I have this and I say, well, I'm working for C++ right now, and they say, well, you need to do one for square, for integers. And you need to do one where doubles, I might have doubles, and well, we need all the families. So now all of a sudden I need to do short, and I need to do all the different integer data types and all the different real data types. Well, we can take this and make a generic one. And the way we do it is we're going to use what's called a function template. All right. So as you can see, comparing these two side by side, this guy works like it's a mold. All right, so I need a declaration up above, template class T. And just like I have int square, I'm going to have T square, where this line up here, when I get ready to use it, whatever data type I want will work. If I have this function square now written, no matter what data type, takes T and puts it here and puts it here, it'll square it and it'll do the return. So just like over here, I'm able to add one more line and have a mold for what's coming up. Some more examples of this. I have 16.7. Here's an example. This is the one we were just looking at, and it actually has the square in it. And then there are a couple examples with square, passing in integers, passing in doubles, actually going ahead and working, demonstrate a working force. Another example, what I can do is template class T, and now I have two variables of the data type. So when I call swap vars, these two data types have to be the same. And as you can see, I have a little swap method. In 161, we did a lot of swapping. Okay, when we were doing our sortings and so on, we did a bunch of swapping. So this would have been nice to have a swap function that I could just throw out there and call swap vars whenever I want. Another example. Class. Now all of a sudden in my template declaration, I have a class T1 and a class T2, which means I'm dealing with a variable type, I don't know what it is here, and a variable type, I don't know what it is here. I have a return type of an int. These guys are reference variables. I come in and I compare which one is larger, and I use the function size of. Size of tells me what? How many bytes? That's right. Very good. Tells me the number of bytes of that particular data type. So if it was int, it would display 4. If it was a char, it would display 2. It would give me those actual sizes for each one. So that's another example of how to use template. Another example of how to use template. I have template. I have some stuff coming in. I have a second template. This one's called sum. This one's called sum. So I'm doing what right now? I had to cover the word up. What's it called when I have same function name, different parameter list?
Overload.
Overloading, right? I'm overloading the sum function. So do I want one? Do I want two of them? Yeah. So this one, well, add them if there's two in the parameter list. Here there's 3 in the parameter list. So I don't know, these templates could be kind of nice. We've seen class templates. Here's function templates. All right. So what do I want you to do? We just look at this 16.8. I said try strings, different data types. You know, we looked at 16.9, we looked at 16.10. Now I want you to go to page 1026, number 3. Uh-oh. Can't find it. Here it is. Write templates for 2 functions, min and max. The min function should accept 2 arguments and return the value of the argument that is lesser of the 2. The max should return the greater of the 2. I don't want you to write a program. I want you to go to your whiteboard or a piece of paper or something where, or even if you want to just type it on in Word or Notepad or something, but I'd like you to come up with these 2 templates. Then we're going to compare and see what everybody has. All right, good. So now we're going to jump back just a little bit to the beginning of the chapter. I wanted to cover that first because this one is now going to have some work for us to do. But templates, check. We're going to back up and go to exceptions. Now, an exception, and so as I'm doing this, I'm starting to think, should I make 162s do some code listings? Because would that have made templates a little easier? I know some of the code we type in is huge, humongous, and I don't want you to type all those in, but I'm starting to reconsider making 162s do some code listings, not for busy work, but for learning reasons. But anyhow, it may come out to help us with exceptions. Okay, an exception is when an error happens. We've had it once that you've seen in 121, unless you've taken 230, then we really get into exceptions. But we're taking a short look at exceptions now in 162. But in 161, you saw this word exception. Does anybody remember where? We dealt with files. In our files, we had something that said throws IO exception. IO meaning input output. So an exception is something where, you know, as you can see, an unexpected event occurs in a program and your program crashes. We just mentioned about a file. We know we have a division by 0 error, could in fact crash our program. And there's a lot of different things that can do it. Like I said, we really get into it in 230, but it's good to see a little bit of it here. Now, when an exception happens, okay, when this error happens, we say we're going to throw the exception. Goes back to that statement, throws IO exception. Yeah, Stephen, we saw it in 121. That was the working with files. But no, nothing in 161. So an exception occurs, and when it occurs, we throw it. Okay, and you're going to see what's going on. And of course, if we're throwing something, we should be able to catch it as well. Well, more terminology. I have this exception, and I need to handle it. So when an error occurs, I throw an exception, and when I throw it, I have to handle it. Now, the way it gets handled is we come up with this try and catch block, okay? And when the error occurs, it's going to occur in our try block. And what I mean by try block is a block of code that has a bunch of statements in. And if an error occurs in there, it's going to throw it to, and we'll have different catch blocks of code that's where it jumps to. It's almost like a good old-fashioned old school go-to. A lot of you don't remember what a go-to is or know what a go-to is, but in the good old days, we wrote our programs, we had to use line numbers all the time. I mean, you typed it in with the line number. Now we can turn on Control L and turn it off. We had line numbers, and if we were at a certain spot and we thought, oh, I need to jump, we would put in a go-to 100, and it would jump down to 100. And 100 could be a line, and all of a sudden it says, go to 660. We would jump to 660. So all of a sudden students were putting go-tos here and go to there and go to there. And it resulted in something called spaghetti programming. Because if you hand traced it, your lines are going all over the place. So that's an old-fashioned term, spaghetti program. We don't have go-tos. We had something similar to it with a break statement that would break us out. But we actually don't have these go-tos. But this is kind of that same thing where if something happens, I can send it somewhere else. All right, so let's take a look at the first example. And oh, I can't move my camera up. I can do this. I have an example, and I'm coming along in this program, and this is the one I just mentioned a moment ago about possibly having a division by 2 error. So I come in and I take a look at my try block. So I'm just putting try, and I'm encapsulating these 2 lines of code. And in these lines of code, if something bad happens, I'm going to throw my exception to hopefully this catch block. Now this catch block is one called exception string. Okay, I could have multiple catch blocks because I could throw a bunch of different things. I could throw things that C++ or Java creates, or I could throw some things that I create on my own. All right, so I come in, I call divide. Now I'm going to go to divide. I come in divide, and all of a sudden I do, the denominator 0. I create this string called exception string, and I'm going to throw this string, throw it to be caught in exception string. And when I get to this point, I see out it, and it'll display that message that we had stored in exception string. Okay, so this is a variable that I'm throwing. Normally we'll throw objects, okay, but right now I'm just throwing a string. It's going to come over and it's going to land in this catch block, pow, and it's going to print it out. The advantage of that is, here, if I do this, I catch it and take care of that error message, I can keep going in the program. The program doesn't crash or have to end. It can keep going. So we can almost use this with input. If it's bad input, I could put this in a while loop so that it keeps running if I so chose. Now that's a simple example of what we're dealing with so far. Okay, now a moment ago I said that was throwing a string. What we're going to take a look at now is throwing an object. Now, in order to throw an object, it has to be of a type class. So what I'm going to do inside of my rectangle.h, my class declaration for rectangle, is I'm going to put in a little inner class. I'm going to put a little class in my class. I'm ready for Friday night, a little class in my class. Never mind. All right, so I have a class. There's nothing going on in this class right now. It's just a class. It's called negative size. So if I get ready and I come over to my, let's get that out. If I come over to my implementation file, I see I have a couple of methods that were declared in my spec file. And in each one of these methods, right, wrong class. Each one of these functions, you're going to see I can throw a negative size. This is what right here, negative size, empty parentheses. What am I throwing? Well, remember, negative size is a class. So what's going to be thrown here is an object of that class. So if I call set width and I come into set width, and if the width is greater than 0, great. If it's not, I'm going to throw an object over to that class. Well, right now it doesn't do anything because I don't have anything specified over there. Okay, but I have an inner class in my header file called negative size. I can throw it from there. I can throw it from here. So if I now come to my try block, I come in and I do this actual set width. That could throw an error. That would throw an error of this type, which means I would now, remember it's throwing a negative size error, and when it throws it, it's going to be caught down here. Okay, let me say it again. On this previous page, I said I'm throwing an object. I'm throwing a negative size object. When I throw it, I'm throwing it to a class. Now, all I did was throw an object. It's an empty constructor, so there's nothing going on with it, but it lands in this catch block because this catch block is catching an object of the rectangle class. It just catches it right now. And once it lands in here, I just display a simple message. Now, in a moment, we're going to up the price of poker. When I throw my object, I may have something I want to throw. I might have a parameter over here and throw negative size, right? Which means if I put something in here that might be a string or a double, that in my header file, I need to have constructors that work with that. Let's look at it. Okay, well, before we do, I want to show that we can have more than one inner class inside of rectangle.h. I can have one for negative width. I could have one for negative height. I know, I'm trying here, folks. I saw Matthew yawn, I saw Brady yawn. I'm waiting for Anna because they're the three that I can see on my screen. And as oh no, okay, try block. If I go to set width, it goes over there and it throws an error. It's coming down to the negative width catch. If I throw an error of the other type, it's going to land in this negative length catch. And again, I don't have anything as far as parameters or more information other than this is where it's to go. And some of you are saying, well, can't we just use an if statement? Yeah, you can, but we're building, we're learning the process of how to throw this. I know by now you would think you folks would understand the baby steps part of what we're doing because it's going to lead into something more exciting and oh, I just can't wait. I just can't wait. Okay, so here was a demo. Again, it's the same kind of thing. You know, I have my try block, I come in, and if no exception was thrown, you know, we just keep going. Here's the negative width catch. Down here's a try block for the negative length catch. All right, now the good stuff. Pow. I'm going back to my header file. Okay, my header file. I have length and width. Good, nice. Now I have my negative width class. And inside of this negative width class, I actually have a field called value. Is chat turned on? I'm afraid you folks are chatting back and forth saying how bored you are. I'm recording it. I can always go look. All right, private double. Public. I have a constructor. The constructor looks like it's bringing a value in this time. So when I call, you know, when I throw this guy, I better be throwing a value in because it's going to come in and store it here. And then inside of this negative width class, I actually have a function that I can use with that object. So when I throw my object and when I catch it, I'm going to be able to catch an object that I'm going to be able to find out what that negative value was. So now this empty inner class is starting to get some things inside of it. Pow. Again, if I have a negative width, if width is greater than 0, I'm throwing negative width, but this time I'm throwing it with that value in. So it's going to go and call that constructor and store this value so that when where are we at? When I get to my catch block, I'm catching an object and I'm actually going to call that object E. And the reason we call it E is for exception. Okay, you can call it whatever you want. But now this E is coming over And remember the function that was inside of that inner class? It allowed me to get that value. So when it was a negative, it then sent it to, when it instantiated the object, it sent it over. And now here's the object coming in, and I can get the value by e.get value of that actual object. Questions? Comments?
I have a question.
Yes,
So in C++, it's not like Java where there's finally bugs, correct?
correct.
Okay.
Okay, so again, we took a look at Rectangle versions 1 and 2. Did I give you code listing 16? Does anybody know?
I don't think so.
You posted the 16 in D2L.
It is in D2L. Okay.
Yeah.
So you would be able to get at those. All right. So that version 3 is the one that just passed an argument value to the constructor. Okay. And then we had a method in there that allowed me to go and get that value that's stored in that inner class. It's what we just did. So what I want you to do is take this version 3 now, version 3, and I want you to go into it, and I want a get area method added, and I want to have you put in, when you start dealing with the area, if it's greater than 100, that it's going to throw an exception so that we have a warning message, because our truck can only handle 100 square feet of wood. I don't know, something like that. So we need a warning message sent. So take your length, take your width, upgrade your program so that it deals with area, have a get area in it, and then put it inside of a try and catch block in case the area is over 100. Questions? Everybody understand what we're asking?